Welcome back to my YouTube channel, Master Tutorials, where mathematics literacy begins. Please do well to subscribe to this channel so that whenever I post any video, you'll be the first to receive it. Alright, so we are still on Math 103, Subsidiary Mathematics, Elementary Calculus. So now we'll be treating it implicit differentiation. Implicit differentiation. Sorry. So now, the differentiation we're doing was explicit. Was explicit differentiation. When you say explicit differentiation, we mean the function y must be in terms of what? X, right? The function y must be in terms of x, which means that if I have f of x, this function f of x is in terms of what? X, right? So I have, let's say, if I have x cubed minus 3x squared plus 4x minus 9. So this one is an explicit function because it's in terms of what? X. So I can easily what? Find for my what? dy over the x, which means I can differentiate y with respect to what? X. Now, when you talk of implicit differentiation, this time around, your f of x will never be in terms of what? X. But this time around, it will be in terms of what? X and y. It will be in terms of x and y, which means that if I have f of x, y, so this one is a cubic function. So I can get another curve, which can be, let's say, x squared y plus 9y squared minus 2x. So we can get this. This one is not in terms of what? X. It's in terms of what? X and y. So it means that we have two variables here. So this is what? An implicit what? Differentiation. An implicit differentiation. So now we are coming to try our hands on how to what? Differentiate implicitly, right? The other time we're differentiating explicitly, right? So we want to differentiate implicitly. So now we have notes how to differentiate implicit functions. One, differentiate 10 by 10 on both sides with respect to what? X. We are differentiating 10 by 10 with respect to what? X. 2. Bring all terms with y over the x to the left and all terms to the what? To the right. 3. Make dy over the x the subject of the what? Equation. So this is how we remove it, right? So let's take it. I'll be saying one or two things when we are solving that. So kindly follow me as we start. So now let's begin with example 1. All right, so let's see. Examples. Find the y over the x of the following curves. Right. Question 1, x squared plus y squared equals 4. 2x squared plus 2y minus y squared equals 5. Question 3, x cubed plus y cubed equals xy. Question 4, x cubed plus 4xy squared minus 7 equals y cubed. Question 5, y squared plus x cubed minus y cubed plus 6 equals 3y. Last question 6, if x squared plus y squared equals 2pxy, where p is a constant, find y prime. We have to find y prime. So how best can we solve this? So now, I'll solve 4 examples and I'll give you 2 to go and try. I'll solve 4, then I'll give you 2 to try. So now, let's see. So, solution. We'll be starting with 1. We'll be starting with 1. Solution 1. Alright, so now, let's see. If I have x squared plus y squared equals 4. Now, they say we should differentiate 10 by 10 on both sides with respect to what? X. But this time around, we are dealing with implicit function. So remember that this one we use chain rule, right? But I'll teach you the tricks then. Don't worry yourself to use chain rule. But what we are doing, we are specifically using what? Chain rule, right? So remember to treat y as a function of x because this one is implicit and we are differentiating that with respect to what? X. So remember to treat y as a function of x. So now let's see. So we want to differentiate this guy. So we differentiate 10 by 10 on both sides with respect to what? X to bring all terms to the y over the x to the left and all terms to the right. So we make y over the x the subject of the what? Equation. So one differentiate 10 by 10 on both sides with respect to what? X. So now let's see. So differentiate with respect to x, differentiate the whole expression, which is x squared plus y squared equals d dx with respect to d dx of what? 4, right? So now let's see. Differentiate with respect to x of what? X squared plus differentiate with respect to x of y squared. Then we differentiate with respect to x of 4. So how best can we solve this question? So let's see gradually. So now if we differentiate this x squared with respect to x, you know that this is x squared, right? So 2 comes down. So we subtract 1 from the exponent 2, so we get 1. Then plus, now I said treat y as a function of what? X. So you are differentiating this y squared with respect to what? X. If it was explicit function like this guy will go to 0, that one we don't know what it's, right? Now this time around, because it is what? Implicit, we are treating y as a function of what? X. So now, if you differentiate y squared, you get 2y, right? Now, if you get your 2y, make sure that you have to bring the y over what? The x. Because we are differentiating y with respect to what? X. Treat y as a function of x. Let's say if you have 2y and you want to differentiate 2y with respect to what? X. 1 comes down, so we get 2. Then we subtract 1. So this guy goes to what? 0. Don't forget to bring what? dy over dx. Alright. So which must be equal to, this is a constant. So we get what? 0. Alright. So now let's see. What do we do? The step 2, bring all terms to dy over x to the left and all terms to the right. So this guy is having dy over x. So we bring it to the left. So we maintain it there. So it is 2y dy over dx. Then we send this to x is not having y over the x. We send it to the right hand side. So we get negative 2x. Right. So now what do? We make y dx the subject of the equation. So we divide both sides of the equation by what? 2y. So I get 2y dy over dx divided by what? 2y equals 2x divided by what? 2y. You can see that this guy cancels out. Right. So now I can also see that this guy will be. So I get my y over the x, which must be equal to x over y. X over y, which is dy over x. Very, very simple and very, very trivial as well. Alright, so x squared plus 2y minus y squared equals y. So now let's differentiate. We are differentiating this function with respect to what? X. But remember that we treat y as a function of x. So now we get d dx of x squared plus d dx of 2y minus d dx of y squared equals d dx of 5. Right. So now we are differentiating this x with respect to what? X squared. So So if you differentiate x squared, you get 2x. Then you differentiate 2y. If you want to differentiate 2y, so we can see that 1 drops, so it multiplies to then we subtract 1. So here goes away to what? 1, right? So 1 times 2, we get what? 2, right? So which means I get my 2. Remember that we are treating y as a function of x. So we differentiate y with respect to what? X, which must be equal to, sorry, I have minus dx of y squared. We differentiate y squared with respect to what? X. We get 2y dy over 9x, which must be equal to, we differentiate a constant, 0. So now here, all the dy dx at my what? Left hand side. So I have 2 dy over x minus 2y dy over x equals negative 2x. So now what do? We have to factorize dy over x. So dy over x out. So we get what? 2 minus 2y equals what? 2 negative 2x. Right? What do we do again? Divide both sides by 2 minus 2y. So I get my dy over x, 2 minus 2y divided by 2 minus 2y, which must be equal to negative 2x divided by 2 minus 2y. So that this guy will go away. Then I get my dy over the x equals negative 2x all over 2 minus 2y, which is very simple and very trivial as well. Very, very simple. Our next example. All right, so question 3, x cubed plus y cubed equals xy. So we want to solve this question. So we differentiate with respect to x of x cubed plus we differentiate with respect to x of y cubed, then we differentiate with respect to x of xy. So now, how best can we solve that? How best can we solve that? So let's see. We are differentiating. All right, so let's see. How do we differentiate x cubed with respect to x? So 3 comes down, then we subtract 1 from the exponent. So we get to the power 2. Then plus. We want to differentiate y cubed with respect to x. I said treat y as a function of x. So 3 down, then we subtract 1, which we get to 2. Then remember dy over what? Dx, which must be equal to, now don't forget, we are differentiating this xy with respect to x. We are treating y as a function of x. So it means that we will apply what? Our product rule. Because y is a function of x. So we want to apply our product rule. And I told that product rule is what? uv. You hold u constant, then you differentiate v with respect to x, plus you hold v constant, you differentiate u with respect to x. So this is what we apply here. So it means that I'll hold what? X constant, then I differentiate y. So if I differentiate y, I'll get 1 times what? My dy over what? Dx. Plus, this time I'll hold y constant. Then I differentiate x with respect to x. You get what? 1. So which is very, very simple and very, very trivial as well. Take note of that. So now we have 3x squared plus 3y squared dy over the x equals x dy over the x plus y. Now we have dy over the x here, dy over the x here. I have to send this guy to the left hand side and this guy to the right hand side because we want dy over the x. So I have 3y squared dy over the x. Then I have minus x dy over the x equals, I have my y. Then this guy comes, you get minus 3x squared. What do we do? We factorize. So dy over the x must be equal to 3y squared minus x, which must be equal to y minus 3x squared. Y minus 3x squared. So now let's continue. What do? We have to divide both sides by 3y squared minus x. So we get dy over the x must be equal to, sorry, we divide both sides, so I have 3y squared minus x divided by 3y squared minus x, which must be equal to y minus 3x squared divided by 3y squared minus x. So the y, I get my dy over the x. So therefore, which must be equal to y minus what? 3x squared over 3y squared minus x, which is very simple and very, very trivial as well. So we'll be solving our last example. All right. So let's see question 4. X cubed plus 4xy squared minus 7 equals y cubed. So we differentiate each term with respect to x. So here too the same thing. We differentiate each term with respect to x. 4xy squared, then minus dx of 7 equals dx of y cubed. So we have this. We have that. Yeah. So now let's see. So if you want to differentiate x with respect to, if you want to differentiate x cubed with respect to x, we get what? 3x squared. Because 3 comes down, then we subtract 1. Remaining what? 2. Then plus. So we can see that I have 4xy squared. Right. 4xy squared. Now this one, we have x, then we have y. We are multiplying. I said treat y as a function of what? X. So we are treating y as a function of x. That's why we are saying that we are multiplying, so we can apply the product rule. The product rule. So now here, I take this as my u, then I take this as my v, right? So I get my u div over what? Dx plus v du over what? Dx, right? So you have this. So your u is what? 4x, right? Then you differentiate v with respect to what? X. I get my 2y, then dy over dx, don't forget, plus what is your v? Y squared. You differentiate u with respect to x, you get 4. So I'm differentiating this u with respect to x, I get 4. So I have 4 to 8y dy over dx, plus I have my 4y squared. So this is what we have to do. This is what we have to do, which is very, very simple and very, very trivial as well. All right, so let's see dx of 4xy squared. Let's see that again. So we are differentiating 4xy squared with respect to what? X. So I said I'll take this as my u, then I take this as my what? V, right? So I said we have to use what? Product rule, because y is a function of what? X. So we are using product rule. If it was explicit function, we can use product rule, because y squared or y will be what? A constant, right? So now here, so y squared will be a constant. So we just differentiate this x, then our way we move on. But because it is implicit and we are treating y as a function of x, then we have to apply our product rule here. Our product rule. So we are multiplying u times v. So I hold 4x constant, right, times I differentiate y squared. So 2 down, then I get my y, which means we subtract 1, we get 1. Then my dy over dx, don't forget, plus, we hold y squared constant, then times we differentiate 4x, which we get what? 4. Right. So now I have 4x. This one is 4x. I treated it as what 4 times 2, which is wrong. So it is 4x times 2y, which I'll get 8xy dy over dx plus this guy, we get 4y squared, which is very, very simple. Very, very simple. So this is what we have to do here. So I've done it here, so I'm going to write it very straightforward. I'm going to write the whole of this down. So I have my 8xy dy over dx plus 4y squared. Then minus, I differentiate this 7 with respect to x, which is a constant. So I get 0, which must be equal to, I differentiate y cubed with respect to x. Y cubed, I treat it as a function of what? X. So I get 3y squared dy over what? Dx. Dy over dx. So now, let's see. So let me clean this place and let's see. So I have my 3x squared plus 8xy dy over dx plus 4y squared equals 3y squared dy over dx. Right. So which is very, very simple and very, very trivial as well. So now, dy over the x, I have dy over the x here, dy over the x here. So I send this guy to the left hand side, I bring this guy to the right hand side, this guy to the right hand side. So I have my 8xy dy over dx, then minus 3y squared dy over dx equals, I get negative 3x squared, negative 4y squared. Then here we factorize dy over dx out. So I get 8xy minus 3y squared equals negative 3x squared minus 4y squared, which is very, very simple and very, very trivial as well. Follow me. So now, what do? You have to divide both sides by what? 8xy minus what? 3y squared. So dy over the x. So I have 8xy minus 3y squared. The same thing, 8xy minus 3y squared equals negative 3x squared minus 4y squared divided by 8xy minus 3y squared, so that this one goes away. Right. So I have my dy over the x, therefore, which must be equal to negative 3x squared minus 4y squared all over 8xy minus 3y squared. So that is our derivative of y with respect to x using the implicit differentiation. So now, I give you question 5 and question 6 to go and what? Try. Question 5 and question 6. Try it very, very well. Don't make any mistake. Take your time and try. Master tutorial say what? Where mathematics literacy what? Begins. Please do well to subscribe, like, share my YouTube videos, drop anything you have it at the comment section. If you don't understand anything, you drop it at the comment section so that when I get time, I'll read it for you. Thank you and have a nice day.